Hi gang, this is just a quick overview review of slope and forms of linear equations to help you with the material in section 1.4 of the homework. That's homework set 4, I believe. There are worked out videos from the author that show examples of the various types of homework problems, and you can link to those from the exercises. So I won't go in depth with examples. But I just want to give you that review overview to get you back into material you probably have studied before. So anyway, a line, of course, is defined by any 2 points in the Cartesian plane. If I have 2 distinct points, that gives me a definition of a straight line. And I want to be able to work with these lines and interpret equations and graph from equations or find equations from graphs, etc. The first thing we want is to develop a theory of slope, some way of measuring the quote-unquote steepness of the line. If you imagine moving along the line, reading this from left to right, this one actually rises, right? With an increase in the x-coordinate, you get an increase in the y-coordinate. This will have a positive slope, and you probably recall that slopes are defined for rising lines with positive slopes or falling line with a negative slope, a horizontal line with a 0 slope, and a vertical line with an undefined slope or no slope. Let me scroll down a little bit here and flesh out my picture a little bit. And this is it's actually maybe shockingly familiar that I've added this triangle much as we did when we developed the distance formula and found the length of these distances, so that basically between the first point and the second point we see that the change in horizontal coordinate is x2 minus x1, this distance, also known as delta x. So you're going to see this symbol with a little triangle now. You'll see this in calculus as well. This is the change in x, how much x coordinate has changed. And the vertical change, of course, is y2 minus y1. From this point to this point, we get this much vertical rise, and that's also called delta y. And then the slope formula is, if I can get my head out of the way, is slope, we use m to stand for slope. I'll get me out of here entirely. We use m to stand for slope. It's the ratio of rise over run. That's the change in y divided by the change in x. And for a absolute formula for there, just y2 minus y1 over x2 minus x1. Am I still in the way? There's the slope formula, y2 minus y1 over x2 minus x1. Okay, so let's talk about forms of linear equations then. It says that I'm hidden, but I still see me in the way. The slope-intercept form, I'm hoping you remember, is y equals mx plus b. Basically, if you have a linear equation that's got y isolated, and over here a number times x at a constant value, that will be an equation of a line in slope-intercept form. The slope is the coefficient on x, is m, and the y-intercept is the constant term, the b. Well, actually, the y-intercept technically is 0, comma b, right, as an ordered pair. So an example of how you might use this, if we wanted to graph the equation 2x plus 3y equals 9, and basically if you recognize no exponents besides 1 on x and y, and just multiples of x, multiples of y, and constant terms, this is characteristic of an equation that will graph as a line. If we solve for y in this equation by adding, subtracting 2x from both sides and then dividing by 3, we can get the equation into the slope-intercept form. So this is in the mx plus b form, where m, negative 2/3, tells us the slope, and b, this plus 3 tells us that the y-intercept will be 3. And then to graph that line, you could simply locate the y-intercept. There's the 0, 3. And then using that the slope is negative 2/3, write the slope in two different, as a fraction in two different ways. Either negative 2/3, or, although we don't usually write it this way, you could write an equivalent rational value, 2 divided by negative 3. And then if you think rise over run, starting at your intercept point, rise of negative 2 with a run of 3, and I've shown that here. Run 3 units, forward 3 units, and rise of negative 2 down 2 units, you locate a point on the line. Or, with the fraction written in the other form, change the sign of numerator and denominator, you can do a run of negative 3, back up 3 units, and a rise of positive 2, go up 2 to locate another point. And that's a quick way of graphing lines that are in the slope-intercept form. Another form of linear equations that's very useful is the point-slope form. Y minus y1 equals m times the quantity x minus x1. And this is great for finding equations of lines when you're given a slope and a point. You know, if the line goes through the point x1, y1 with slope m, you just fill in this information and you get an equation of the line. Here's maybe a more realistic or more difficult example of where you would use this. Example, find an equation in slope-intercept form for the line through the point negative 2, 5 and perpendicular to the line y equals negative 2/3 x plus 3. Oops, introduced another idea, perpendicular. Recall that parallel lines have identical slopes. Two parallel lines, lines that, you know, cruise along at the same kind of attitude and never touch each other, those will have the same slope, m1 equals m2. Whereas perpendicular lines, lines that meet at 90-degree angles, these have the relationship that the slopes are opposite of reciprocals of each other. That's a mouthful, but basically the product of m1 and m2 equals -1. m1 times m2 equals -1, or as I've written it here, one of the slopes will be found by just taking the reciprocal 1 over the other slope and also changing the sign, the opposite of the reciprocal. So back to this example, we're trying to find an equation in slope-intercept form, so y equals mx plus b form for our final answer, for a line through a given point and perpendicular to a given line. Okay, note that the line we're perpendicular to is in slope-intercept form, so it has a slope of negative 2/3. Here's my solution down here. If I can get to it. The given line has a slope of negative 2/3, so that means that excuse me a second. All right. The given line has a slope of negative 2/3, so that means that a perpendicular line has a slope of 3/2. Reciprocal would be 3 over -2, flip the fraction upside down, change the sign, you get a positive rather than a negative. So a perpendicular line has a slope of 3/2. And now I can use the point-slope form and say, here it is again, y minus y1 equals m times quantity x minus x1. I'll put the known slope in place for m, and I'll put in the point that I know I'm going through, which is negative 2, 5, in for x1 and y1. So substituting negative 2 for x1, I get x plus 2, and substituting 5 for y1, I get y minus 5. But I'm supposed to give my answer in slope-intercept form, so I want this to wind up y equals mx plus b. And I'll just multiply out you know, a distributive property here and add 5 to both sides to isolate y, and here's my solution. Y equals 3/2 x plus 8 would be that line through the desired point with the desired slope. Okay, basically the stuff in the boxes is what you need to have as memory material for doing these assignments. You should know the relationship between slopes of parallel and perpendicular lines. You should know the point-slope form, memorize this guy, y minus y1 equals m times x minus x1, and know that that's the point slope form because it's an equation when you have a point and a slope. Know the slope intercept form, y equals mx plus b, and know what that's good for. And finally, remember the slope formula. Rise over run is a good way to remember it. Change in y over change in x, vertical change over horizontal x over horizontal change. And of course, that's the difference in the y coordinates over the difference in the x coordinates for a pair of points. Have fun!